A charge particle Q is shot towards another charge particle Q, capital Q, which is fixed. If this is capital Q, which is fixed, and small q charge, this is shot with a velocity v, right, the speed v. It approaches Q up to a closest distance r and then returns. So basically, if this is the distance r, this charge comes up to this point and it returns back. Why does it return back? Because this is having an electric field in this direction. So basically a force will be acting on this charge. So what will happen in this case? It is having, right now it is having some energy. Let us assume that it is at a distance infinity basically from this capital charge Q, right? So when it is at infinity, potential energy is 0, U initially 0. So at right now it is only having kinetic energy, which is half mv square, right? Now when it comes, it approaches this charge Q, its potential energy increases, and so basically, and due to energy conservation, the change in kinetic energy or the decrease in kinetic energy will be equal to the gain in potential energy, right? So when it comes at this distance, what will happen? At this point, velocity will become 0, right? Because it is changing its direction, right? So at this point, if this is point A and this is point B, what is the decrease in kinetic energy? Decrease in kinetic energy is half mv square minus 0, right? Because finally it is 0. And what is the increase in potential energy? Initially the potential energy was 0. Finally it has become kq small q upon the radius r minus 0. Initially it was 0, right? So that means it implies that half mv square equal to kq by r, right? Now let us mark this equation 1, right? Now what happens if this particle, this small charge q, which is at a point A, it now approaches it with a velocity 2v, this charge, right? So let us assume that at a distance x it will have velocity 0, or it will return from this point, right? This will be the minimum, the distance of closest approach. So again, using this delta ke equal to delta pe, it implies that delta ke will be now what? Half m 2v whole square, right? Initially its energy was half m 2v whole square. Finally it will become 0 at point B, right? Because it has to return from this point. And what is the change in potential energy? This is kq by x, right? We have to calculate the value of x over here. It implies that 4 into half mv square, 4 into half mv square. And what was half mv square for one equation? It was kq by r. That means 4 into kq by r will be equal to kq by x. So from in this equation we can easily calculate x will be equal to what? R by 4. So the distance of closest approach will be r by 4. That means option D will be correct.